Hello everybody, we are going to talk today about acid nomenclature. So how to name acids and write the formulas for them. So first of all, you have to know what an acid is in order to name it. So whenever you see an acid, almost all the time there will be an H in front of the formula. Hydrogen is always a part of the acid because that is that's kind of the definition of an acid, is has an H that it's willing to give up. So once you identify that it is an acid, there's really three different ways that we are going to learn how to name the acid, and it's based on the anion, the end of the anion. So there's three different ways. So an anion will either end in "ide," like chloride, bromide, phosphide, things like that, sulfide. It will end in "ate," like nitrate, sulfate, phosphate. That's for polyatomic ions. Or it will end in "ite." That'll be like nitrite, phosphite, sulfite, things like that. So depending on which one it ends in is how you're going to name it. So if it ends in "ide," we will name it hydro blank ic acid. So it will be hydrochloric acid. The blank is kind of what element we're talking about. Hydrochloric acid, hydrobromic acid, hydrofluoric acid, a lot of different ones, but those will all end in "ide, and we always name them hydro blank ic acid. If it's "ate," then we will just call it ic acid, blank ic acid. So sulfate turns into sulfuric acid. Phosphate turns into phosphoric acid. Acetate turns into acetic acid, and so on. So this again will be the kind of the root of whatever element we're talking about, or polyatomic ion. If it's "ite," if it ends in "ite," the anion, then it would be blank us acid, OUS. So for instance, phosphite becomes phosphorus acid, or sulfite becomes sulfurous acid, or nitrite is nitrous acid. So again, these blanks would be kind of the root of the element or the polyatomic ion. So let's do an example of naming and then also writing the formula for these. Okay, so if I have something like, let's say it is H2S. Okay, H2S. Well, again, I know it's an acid because it has an H in front, so what I'm going to look at is the anion. The anion. So when you look at the anion, which in this case is the sulfide, sulfur turns into sulfide. So I know that this is sulfide. So then I look back up at here. If it's "ide," then it's going to be hydro blank ic acid. So hydro, and since this is sulfide, it's going to be hydrosulfuric acid. Hydrosulfuric acid. Okay. Now if it is, let's say we have HNO3. Okay. And again, I know it's an acid because it has an H in front. This is where you need to be able to identify your polyatomic ions. So I know that this is a polyatomic ion, NO3. What polyatomic ion is it? It is nitrate. Okay, so nitrate, I know that it's 8, so it's going to be blank-ic acid. So it's going to be nitric acid. I don't need to put the hydro, I don't need to put anything else, I just simply turn the 8 into ic. So nitric acid. All right. Now the difference between that and this, okay, now I have HNO2, which is nitrite. Nitrite. So nitrite turns into nitrous acid. Nitrous acid. Okay? So that's how you name them. Now, how do I, if I have the name, how do I write the formula? So let's say I have, let's say I have acetic acid. Acetic acid. Again, I know this is come from something that ended in 8 because it has an ic, and this is acete or acetate. So this is acetate, which I know acetate is C2H3O2 -1. That's the formula for it from the polyatomic ion list. So this is going to be the anion. What's the cation for an acid? Always, hopefully you said hydrogen. So how many hydrogens I'm going to put is corresponding to the charge here. So each hydrogen is +1. So I need to add as many hydrogens as to make it neutral. So if this is -1, I need to just add 1 + 1 to the front. So it's going to be HC2H3O2. And there you have acetic acid. Okay. Now, what if I have phosphoric acid? Okay. Well, I know hydro and ic, that's going to be something that ends in ide. And since I have this phospho, okay, that must mean it's something with phosphorus or phosphide. So it's phosphide is just the element by itself, and its charge, it's in group 15, so it's going to be -3. So when I'm writing the formula, I'm going to put H in front, and it will be how many H's is corresponding to the charge. So if this is -3, I need 3 H's to balance out that charge. So it will be H3P. Okay? And that is how you do naming and writing formulas for acids.